Hi, this is Tanumoy. I'm a physics faculty at Cheenta. Today we are going to learn about a very interesting topic that is going to be very useful for all the Physics Olympiad program and all the competitive program. The name of the topic is pseudo forces. We will see how we can use pseudo forces in various problems. So today we are going to take a problem from F is equal to MA exam from 2013, and we will see that how we can implement the pseudo force thing to understand the concept, and also we are going to simulate it on a virtual platform to see how it works in real life. So let's see. So now we are going to understand the concept of pseudo force with a simulation that we can see here. That when we give a force to an object, there is an acceleration in the forward direction from the inertial frame of reference. But from the non-inertial frame of reference, we can see that there is an acceleration that we can encounter. The thing is in opposite direction. Okay, so let's start the simulation. So as the applied force is there is a friction force that you can see that it is in opposite direction. So we can reduce it and we can see only the effect of the applied force. So see, as it is moving and as we increase the applied force, the water in this bucket, so the force inside the bucket is in opposite direction to the applied force. Now suddenly, if we apply force in the reverse direction, see, then it is the opposite direction in which the water gets tilted. At this point the acceleration is maximum and now it is going to move forward. So this tilt of the water in the opposite direction is encountered by a pseudo force which is acting on the particles of the water. But in that frame we can see that it is just in the application from the Newton laws that we can just apply it in the reverse direction, and we can see the effect of it with just applying the F is equal to MA equation in the opposite direction. So this is how the entire scene happens. At the moment when there is no force applied, the water is leveled, as you can see. So we can minimize the frictional effect and we can see that there is no leveling up and rightwards or leftward direction of the water. Just when it applied force is there, then only it get tilted. So let's understand what is a pseudo force. So pseudo force is something that come into play when we are going to take a non-inertial frame of references. So what do you mean by non-inertial frame of reference? Non-inertial frame of references are those frame of references which are accelerated frame of references. So in normal conditions, we cannot understand our own acceleration when we are ourselves in the accelerated frame of reference. So in order to apply Newton laws in that, we have to apply a fictitious force, which is a false force that is named as pseudo force. So here the pseudo means false. So it's actually not there. The cause of its origin is inertia, and it is on account of the real force that is applying in the reverse direction. So it's always applied in the opposite direction of the real force. So pseudo force versus real force. The difference between pseudo force and the real force is tabulated below. So origin, it occurs in a non-inertial reference frame. The real force origin occurs in the inertial reference frames. So what are inertial reference frames? Inertial reference frames are those frames which are at absolute rest as compared to their surrounding nature. The fictitious force is the term used to explain the way things seems to move. So it is actually appear to move. It's not actually moving. It actually appear by the person in a non-inertial frames that something is moving in this way or that way. Real force is a genuine force. Its origin is the actual causality. It occurs when objects interact with each other. Example of the pseudo force as we can take. It's a centrifugal force which occurs in result of a circular motion, and it's a Coriolis force that you can often see in earth rotation, that is also pseudo force. These forces, however, are very important to understand the overall concept. However, the real force, we can say that friction, electromagnetic and gravitational force, these all exist as their original cause is there and they are produced by a real cause. So here we can see a problem from F is equal to MA exam 2013. In this following problem, we can see that a student steps into a stationary elevator and stands on a bathroom scale. The elevator then travels from top of a building. So there is a building. So from the top of a building, the elevator is moving downwards, let's say. To the bottom, the students record the recording on the scale as a function of time. So let's see, here we can see the scale reading of its weight, okay? And here we can see the time as elevator moves. So first it was appears that the weight was 80 kg, that was normal at rest frame of the observer in the elevator. So let's understand the concept that when a lift moves, what happens to the weight of an observer depending on their elevator movement. So let's suppose that this is a lift. So there is this person standing on a weighing machine. So here we can see that as lift is stationary, we can see that the weight of the person, mg, will show downward direction because it is always attracted towards earth. And on reaction, it will apply a normal reaction in opposite to the direction of the weight. So we can frame an equation as there is no acceleration at this time. So we can frame that N minus mg is equal to 0 because acceleration is 0. So normal reaction is equal to the actual weight of the person. So when the lift is at rest frame, this 80 kg weight was shown. So now it is asked, at what time does the student have maximum downward velocity? So to find that, we have to find the acceleration quantity. Okay. So let's see what happens when lift starts accelerating. So let's frame an equation. So now when lift starts accelerating downwards, so the acceleration vector will now point downwards. Okay. There is always a mg component that will act naturally because of the weight of the observer, and the normal component as it is. Now we can say that as acceleration is supporting this mg component, so we can write that mg minus n equal to ma. Getting it? Converting this equation, we can see that the normal reaction is coming out to be ma plus mg. So it will come out to be ma plus g. Okay. So mg minus n equal to ma. So we can see that normal reaction will come out to be mg minus ma. So n equal to m times of g minus a. So here we can see that the actual weight was mg, as when it was at rest, the normal reaction was showing. It was the true weight of the observer. So true weight of the object. So it was 80 kg at that time. Now it came out to be mg, that is normal reaction is decreased by this acceleration ma. So we can write normal reaction is nothing but mg minus of ma. So ma times of decrement will be there. So this normal reaction is nothing but the apparent weight of the object. So this apparent weight will come out to be less than the actual weight, which is shown as 60 kg. Now when it starts moving at certain velocity, it will see that it is following a constant velocity at certain interval of time before stopping the lift. So it moves with this velocity from 4 seconds to 22 seconds. After that, when the lift starts stopping, there is again the effect of an acceleration, but now the direction is reversed. So we will calculate for that also, that what will happen when the direction is reversed, what will happen to the apparent weight of the object. So let's see. So as the direction is reversed, we can see that acceleration is in upward direction. Because now the lift is stopping, so it is decelerating, so it is accelerating in opposite direction. So when something is decelerating, it's actually accelerating in reverse direction. So we can say that n, now we can frame the equation as n minus mg equal to ma, which is nothing that n is equal to mg plus a. Now we can say that the apparent weight of the observer is nothing but increased by the factor of ma. So that's why this state is showing as 100 kg. So this 60 kg and 100 kg, none of them is the actual weight of the observer. The actual weight of the observer is 80 kg. What this is showing is the apparent weight while accelerating downwards, and this is showing the apparent weight while accelerating upwards. So now it has been asked, at what time does the student have the maximum downward velocity? Obviously when acceleration is supporting the velocity component, when it is coming downwards. So it is nothing but at all times between 4 seconds to 22 seconds, it will have the maximum downward velocity. If you calculate for the acceleration value, you will get acceleration as supporting the velocity component, and it will have the maximum downward velocity while it's coming downward.